Welcome back. We're going to run into video 3 for Unit 8, and we'll take a look at finding present value for an ordinary annuity. We'll wrap this unit up with a sequence of word problems that will comprise video 4. So again, in terms of breaking things out in some kind of a logical order, this will probably be a very short video. It looks like we got about 8 or 10 slides in terms of video 3, and then we'll dump out some word problems that have a little bit more of a challenge for us in video 4. So let's take a look at what we got going here. Let me share this PowerPoint with you. Content coming from section 20.2, trying to calculate the present value of an ordinary annuity. All right, so present value is the upfront value so that you can maybe make a series of withdrawals along the way. All right, and once again, the author's a big chart kind of guy, and I just say no thanks. We're going to rely on the formula, even though it's clunky, and certainly it's a pretty good candidate for Excel to play a role for us as well. There is our formula for calculating the present value of an ordinary annuity. I should point out that this text only deals with present value for ordinary annuities, so we'll stay there. We won't consider present value of an annuity due. We'll be calculating only present value for ordinary annuities. If things look familiar, I guess they kind of should. Present value, what's it worth right now? Okay, the today's value. Just as before, N differently than we handled it in Unit 7. It's going to represent the number of compounding periods per year times the number of years, same facet that we saw in the last couple of video actions. And then similarly, I represent the interest rate per compounding period. So we'll take the annual interest rate and divide by the number of compoundings per that particular year. We're going to go right after an example. All right, so the question says, find the present value. We want a payment of $4,000 for 5 years, and our annuity is going to be set up so that we've got 8% compounded annually. So in a sense, what we're finding right now is how much will we have to put in right now so that that 5-year span could go by and you and I would be able to draw out $4,000 for each of the 4 years, or I'm sorry, for each of the 5 years. All right, so there's our formula. Take a look at what we got planned. Okay, we seek a payment of $4,000. All right, N referencing number of years times compounding periods per year. Notice up there it says we're compounding annually, so that's once per year for our 5 years. In effect, 5 compounding periods. And again, in a similar fashion, since it's once in terms of compounding periods per year, the interest rate for each compounding period is the full 8%. There's your plug-in line. Okay. Notice that the N represents the power of 5, which was our 5 times 1. Oh, baby, I'm going to go ahead and add the 1 plus the 0.08. I know you're proud of me. Again, a lot of group action going on. If you're good with the groupings, you can key this in one shot and make it go. And that's probably what I would try to do. All right, you've got a big set of parentheses around that whole second fraction. You're going to have to group the numerator. You're going to have to group the 1.08 to the fifth. So you can't get allergic to grouping symbols if you're going to be successful with your calculator. All right, if you punch it all in well, we find out that the present value of that annuity turns out to be $15,970.84. So that means if we were to right now walk out and invest at the rate and the period of time specified, we gave him $15,970.84. We could, in fact, withdraw $4,000 for each of the 5 years. All right. And the 8% compounded annually helps us along the way. All right. Present value for example number 5. If you got intimidated by that mess to calculate, you could pull it apart. All right, and this screen gives you that opportunity to talk about it. And what you could do is you could start with the 1.08 to the fifth power. The only problem is if you're going to key that into your calculator, you got to be awake because you need to take 1 and divide by that answer. So I'm a big fan of using memory and recall on my calculator. So that's probably what I would do there. All right, so in terms of processing, if you want to pull it apart bit by bit, that's a process scheme that would let you do it. Again, probably making good use of the storage capability, the memory capability on your calculator. Don't have to. If you're good with the grouping symbols, you can rock that whole thing in a one-shot crunch. And that's what I did on the screen. All right, now we're going to head into word problems. And this is an intro screen, but actually this video won't actually contain solutions of specific word problems. We'll see that in video 4. But when you read the problem, some things for us to contemplate. Are we looking at determining a future value at some point ahead of now? Are we looking for the present value right now? All right. Second thing is this an annuity that we're looking at? Is it a sequence of payments, a series of payments, or is it a one-shot deal? Am I putting a certain amount of money in now, figuring out what it turns into later? If it's a single lump sum, that's different than an annuity. All right, if it is an annuity, which kind? Is it an ordinary annuity or is it an annuity due? Because we've seen in the last few videos, we have two distinctly different formulas to play along with those two particular types of annuities. So it's important for us to read the problem critically and draw some inferences before we try to solve. So we will be looking at this as we move into the video 4 for unit number 8, which is basically you and I having a good old time solving some problems dealing with time value of money, present and future. And that's coming up soon. We'll see you soon for video 4.